Welcome back. So in this video we're going to take a look at this DRO unit in particular and just go over some of its features. I've had a couple of requests to do that, and I think it's a good way of rounding out the DRO installation series on this mill. Now, before we get into that, I'd really appreciate it if you'd go and like and subscribe.
Come on! Come on! Oh, okay.
Now that you've liked and subscribed, let's talk about DROs a little bit. First of all, you don't need one, especially in the home shop. If you've been told, if you're new to machining at all and you've been told you must get a DRO, that's not true. You can machine very accurately without one. And honestly, if you're new to machining, you should just get to know your machine, and get familiar with backlash and all the other things, and learn to machine things accurately without the use of one of these, because it'd just be better for you overall. Now, that said, they are phenomenally useful. They just make things easier, but you still have all the same capabilities without one. It just takes a little bit more thought. So yeah, nice to have, but I just want to be clear that you don't have to have a DRO. Now, most DROs have basically all the same functions. This one, I don't think, really provides any extra functionality over other kinds of DRO, but I really like the graphic interface that it has, and so I'm going to show that to you. The other thing is, I got this from DRO Pros. They're certainly not the cheapest people out there, but they are really good people to work with. They're very helpful. They have a lot of excellent support if you need it. I've not needed very much, but they are phenomenal people to work with. So there's other places you can get DROs for less money. You just have to kind of balance out what you want in terms of support, what you want in terms of capabilities and everything else. So they're all valid options. So that's enough of that. Let's look at some specifics. First of all, power it on. Switch is back here. All right, we'll do a little bit of freehand work first. One of the nice things about this particular unit is it has this glass touch screen. So no actual buttons to use. It's all just touch screen stuff, which is pretty nice. So it means it's sealed, and you can get coolant on it and all of that stuff without any problems whatsoever. Some other DROs that I've had, you've had to have a plastic cover over them to protect them a bit, which is, yeah, it's fine. That works perfectly well. So when you take a look, you've got main functions here. You've got your X, Y, and Z readout. The DRO unit itself is in a very nice cast aluminum case. So it's nice and solid and well protected. These ones do have a USB port, so it is possible to do software updates. I've never done that. I don't know if there are even any software updates for this, but it's a possibility if that should happen. And on the back here, there's a probe location, and I'll show you that later on, which is gives you the ability to have a touch probe so that you can use that for accurate measuring. And then here we've obviously got the power cord and this ground cord to connect the machine to connect the DRO to the machine and ground the two together, which is important. And then this one is actually a 4-axis, so I've got a U scale here, and I was planning to install a scale on the quill, but I don't know that I'm ever actually going to do that now. It really isn't that important. Look at the screen then. So obviously X, Y, Z axis. This one is the EL750, which means it's capable of 4-axis readout. On the EL700, they used to actually show all 4 axes at the same time, but they don't offer that one anymore. I expect they didn't sell that many because a 4-axis readout isn't that necessary on an email, to be honest with you. But if you want to see the 4th axis, you just use the arrow key here to go between U and Z. Going around the rest of the display, units are shown here, absolute and incremental mode shown here, probe mode indicated here. This shows the feed rate on the axis that you have it programmed for. And right now the axis is set to none, which means that all axes will read on here, which seems best way of doing it. Across the bottom, function, 0, tool, half, probe, calc. Whenever you see a little arrow down here, it says that there's more options by using the arrow keys. In this case, setup, which is where you get into the main setup of the system, and we'll get back to that. On the screen here, you've got your standby mode. Don't do a lot, does it? Not sure why that's there. Incremental and absolute mode. And you can see as you change between the two, that symbol changes. Unit selection, inches and millimeters. And these 2 keys I'll come back to in a moment. And here is the subdatum memory. Of course, over here are all your numerical keys. Right, so taking a look at the feed rate, when I twist the handle on the tables, you can see that changes. So that I use that mostly on the X, where I have a power feed, so that I can actually set that to a value. But it's not super critical, to be honest, but it's nice to have. One of the most common functions that you do on the DRO, of course, is setting a 0 position and then moving to another position. 2 ways of setting 0. You can select an axis and then hit enter. You've also got the 0 option, which now allows you to just go 0 all of these axes all in one go. In the set position, which we're now in, you can select an axis and set it to a value. The half feature is very useful. I like that very much. Used to easily establish the center line of a component. And you simply 0 using an edge finder at one end of the part, move to the other end of the part, touch off, and then you can half the axis, and then you're ready to move to the center of the part. We'll take a quick look at that. So here we are, got the edge finder in place. So yeah, very convenient, easy way of finding centers. The probe function is a nice function to have. You can actually use that to measure parts. I don't use it very often, but there is a probe available that you can plug into the unit, which allows you to touch off very accurately on components. So this is the probe. This is an electrically conductive probe that's essentially mounted on gimbals, and it is critical to make sure that this probe is running completely concentric to the little spindle on the probe unit. I've not actually checked that and set it up, but this is just a demonstration. So this allows very accurate measurement of parts and therefore also placement of datums, and can be useful on unusually shaped parts, parts with a lot of features, parts that have to be clamped at an angle. Not something I use very often at all, but convenient to have around. So just by way of demonstration, go into the probe screen. Now your basic options are to set datums. MEG means is your basic linear measure mode. ANG is an angular measurement mode, and dia for diameter, for measuring diameters. So we'll go into the linear measurement mode, and you can see these graphics give you an idea of the different kind of measurements you can make that are set up as standard. So internal pocket, external feature, step heights, and widths. So we'll just do a width or length of the part just for a demonstration of how the probe works. The little beep lets you know that it's touched off, and you want to be careful. These probes are actually fragile. And there we are, gives us a length number. So one advantage to this is that the measurement is electronic, meaning, you know, you can do this same thing using an edge finder, but if you over travel on the edge finder, you'll have a little bit of an error. Whereas if you over travel here, the readout is taking the data from the moment that the probe touched the part. So it takes out any inaccuracies from human interaction, as it were. Similarly, angle, you can measure different kinds of angle, and diameter you can measure internal and external. And these are just preset routines that you can work through. So that's a quick look at the probe. On the linear measurement, just go back into this screen. You can also use this to find the midpoint, just as we did before. By using the half function. Potentially a little more accurate than the edge finder. Right, let's take a look at the functions. So under here you have your pre-programmed routines for doing different things. So bolt hole is one of the most common ones. And you've got line hole, grid, frame, arc contouring, pocket, R function. These are all essentially very similar. They basically just set up arrays and patterns of holes for you to follow. So just about any other DRO can do the same thing. It's just a little more long-winded if you have a basic numerical one, because you just have to go and program the bolt hole patterns. This one gives you some preset routines to look at. So if we take a look at the bolt hole, go new, and now you've got the various settings that you have to fill in. So you can program your coordinates of the center, and you just move your arrow up and down to your different items. And for circle radius, you know, for example, 2-inch radius. You can enter your starting angle for the first hole. Maybe that's at 30 degrees. And a bolt hole pattern with only one hole is pretty useless. So let's say there's 5. Depth. This is where you can use the knee, or if you've got a quill scale mounted, you can add that feature on there. And you can select the plane that you want to do, which most of the time is going to be XY, but doesn't have to be. You can, if you had a right angle head on the machine, you could be doing a bolt pattern sideways. Once you've entered these, all of your criteria, you hit the run button, and now you've got a graphical display which shows you where the holes are. And it's nice. It's totally not essential, but you can do each hole. You can see the black dot shows us where we're at, so you can draw your first hole, and then you can move to the next hole. And now this just gives you a nice graphic to follow if you want, and then you've got your accurate dial readings. And once you've drilled that hole, there we are, you can go to the next one, and so on. How much is this little graphic worth to you? Well, you've got to decide that. I like it. It's totally unnecessary, but I really like it a lot. This gives you the option to jump to whichever hole you want. So as you can see, your marker moves around, and then you can go and play chase. The count function just takes you back to the normal screen, and then you can go back to the graphics screen, and of course exit. So the other functions work in much the same way. If you want to do a grid of holes, same thing. You have your start coordinate, pitch in the various axes, the angle that the bolt pattern is at, and that's really where these come in more useful, is when you're not doing a plain XY pattern that's normal to the axes. If you were doing a bolt pattern that was skewed, this just makes it a lot easier. But you can see, same idea. The R function that we're in now is basically just to allow you to program different types of arc. And it's, again, much the same as the other functions. You set your various information, which is basically around the direction the arc goes and the size of the arc, the tool that you're using, the cut size that you want to do, and the depth, and so on. And then you can follow your program.
This diagram is included in the manual that comes with the DRO, and it just shows the different kind of arcs that you can do with the R function. And basically what you do is you pick a start point, the radius, the direction you're going, and the program just calculates the path for you based on your step over. So very simple, and I believe a common function on most DROs.
Basically, all this R function is doing is giving you whatever step over you want so that you can work around the arc with an end mill and accurately machine out the arc. And you can see I'm just indexing to each hole. And so it all comes down to, if you want to make a nice smooth arc slot, you can have a very small step over and just move the table a fraction at a time and take another bite and gradually machine out your arc. A few more of the functions. Slot speaks for itself really. Polar coordinates, you can select which plane you want to put those in. You can turn summing on and off, and if you have summing on and you have both a quill and knee scales installed, it will add those two together, bearing in mind their direction, so that you get a total vertical distance. That was useful to me on the bench mill, which had a column with no hand wheel on it. The way you run a knee mill is slightly different, and so it's just not so important. Zero approach just gives you an audible warning as you approach your 0 point. That can be a handy indicator. Shrinkage factor is something you can apply if you're machining molds and so on. That can be a useful feature. It kind of gives you an offset. So you can take your finished dimensions and apply the offset and not have to recalculate dimensions. And then the feed rate axis is which axis you want to show in the feed rate in the top of the screen. I leave it to none because then it will show whichever one you're moving at the time. Other functions to look at: absolute to incremental mode, unit swap, inches to millimeters, self-explanatory. This is a reference function and allows you to set a home position on all of the axes, so that if you move the tables with the machine powered down and the DRO off, you can return to that location and pick up an absolute position again. So it's just a kind of memory facility, which is quite useful. I haven't set it up yet, but I'm going to. This is the preset key, and this basically is your work to zero feature, and it's for just making incremental moves to preset values. So it's another way of doing a grid pattern, for example. So if you go into this, you can program values for the different axes, and then you basically can just recall those values by pressing the button. So go to 0, drill your hole, recall that axis value, and what's interesting is it accounts for any error. So maybe the tolerance is really wide, right? And I go, oh, I can't be bothered to go to exactly 0. This is close enough. Drill your hole, now recall. And now the next move is 247. So you get back onto your pitch. So suppose that could be useful. You know, yeah. So this is the sub-data memory. Potentially very useful if you're actually a job shop and you actually have parts that you have to make multiples of, and you can basically program a series of holes or features using this sub-data memory and just repeat the program over and over. So I'm not going to go into how to program it because honestly I don't see myself ever using this, but I can see it being hugely beneficial in an actual production environment. So an excellent feature to have, not one that I've explored. Right, so quick look then at the setup features, and you'll see there's a little tiny arrow down here which tells you that you can scroll over, and this is where the setup menu is. So factory setup, don't know how you get in there, but that's, you know, that's for setup back at the factory. User setup is more useful. So here you can set sleep time, you know, how long the screen goes before it just shuts off, whether you want your keys to beep when you touch them, zero approach beep, zero approach tolerance. Got a diagnostic mode here to check out encoder's keyboard on this unit and the probe. Under select axis, you can go in, and this is where you can add compensation if you need it. Now, obviously you want to try and get your scales all set up so they're reading accurately, but sometimes I guess you can find that you need to add a scale factor. I don't have it on any of the scales I have, and there's two ways of doing it. The manual takes you through those. One is a linear compensation where it's just a scale factor. The other one allows you to program different compensations for different parts of the scale, so you can have different compensation factors along the length of the scale, which could be important, especially on larger machines. And you can do all of that through the calibrate axis. Okay, so there you go. That's a brief look at the DRO Pros EL750 DRO readout unit. As I said at the start, there's many options for digital readouts, including just not having one. All perfectly valid. I don't know that this one offers functions that others don't have particularly. I do particularly like the graphical display, but each to their own on what works for you. There are many less expensive options that are just as accurate, but I have been very pleased with the quality of this brand and of the quality of support I've received from them. So I thoroughly recommend them, but I understand the price point doesn't work for everyone. So with that, I'm going to end it here. It's not a particularly well edited video. I'll be honest with you, this is a really tough subject to do, to actually teach ins and outs of a digital readout. It's a pretty dry subject. So the idea is just to provide a little bit of information for anyone considering one. If there's something specific you want to know, shoot me a note, send me an email, and I'll tell you about it. And if there's a lot of interest in something specific, I'll demonstrate it. But my gut feeling is this video won't get seen very much, but it will be out there for anyone who wants to know. So in the meantime, stay safe and well. May your dimensions be in tolerance and your service finishes chatter free. And as always, be seeing you.